We're going to look at graphing functions in order to help us find the domain and range. The first function we'll look at is h of x equals the difference of 3x and 7 divided by the sum of 3x and 2. We will be using the y equals key for entering the function. Let's go to the calculator and turn it on and go to the y equals key, which is in the upper left-hand corner. Notice there's y1 through probably y10, and we'll use y1 rather than h of x. And the only variable we can use on the right side is the variable x. It's always a good idea to start out by putting parentheses around your numerator and denominator if they're needed, because otherwise you might forget to enter them when you're entering the function into the calculator. Let's open parentheses and then 3x minus 7, close parentheses, divided by, open parentheses, 3x plus 2, and close parentheses. Alright, now when we go to graph this, we usually hit Zoom 6 first to get the graph into the standard 10 by 10 window. And you can see that something crazy is happening around 1, in the vicinity of 1 there. And this is often, it tries to connect often when there is an asymptote there. And one way that you can get around this is to go into the mode key, and instead of having it connected, enter it as dot. And you may want to go back and hit enter, switch it to dot, a dotted graph, and then go back to graph and see what it looks like. And you can see it does seem to have an asymptote there, but it's pretty hard to see what the asymptote is. In this graph, we're going from negative 10 to positive 10 with 0 in the middle, and from negative 10 to positive 10 on the y-axis too, with 0 in the middle. And it looks like everything's happening around between negative 2 and 0. So let's change our window on the x-axis to see what's happening there. And it's a way of zooming in, but we're not changing the y-axis at the time. So let's go from negative 2, minimum value of x, to a maximum value of x of 0. And the scale is 1, that means we'll have a tick mark at 1, or negative 1. And on y, we're still going from negative 10 to 10. We may change that, but let's just see what we have. And hit graph. And you can see it does seem to have an asymptote, but it doesn't seem that we have enough y values to see exactly what's happening. I'd like to go up higher. Let's go to 50 and down to negative 50 and see if we can tell a little bit more about this graph. And let's go back to window. Let's go from negative 50 to positive 50. And for my scale, which tells me how many tick marks, I don't want 100 tick marks on the y-axis. So I'm going to put it at 10 instead of 1. Just every 10 there's going to be a tick mark. Alright, well let's hit graph to see what this does. And we see an asymptote indicated somewhere before we get to negative 1, here's 0, here's -1, here's -2. And on the right side we have 10, 20, 30, 40, 50, and it definitely seems to be going up there, and coming from the right it's going down. So if you're looking at the, and if you look at your denominator, you can see that if you solve equal to 0, you're going to get -2/3 as a value that x cannot equal. And sure enough, that seems to be the asymptote there at -2/3. But we can see that we see that our domain excludes -2/3, and our range seems to exclude 0 here. It seems to have an asymptote at 0. Alright, so you can use the window key to rearrange your range and domain, change your range and domain so that you can kind of zoom in just on what you want to see. Alright, let's look at another function, and this one has an absolute value in it. P of x equals the absolute value of x minus 1 added to 3. Alright, let's go to the y equal key again and clear out the function we had in there before and enter the absolute value function. To enter an absolute value, you go to the math key and then the num to the right there, number menu, okay, it's num, and the first thing down is absolute value, so hit enter, and then you're going to put the expression that's inside the absolute value in parentheses there, so we'll hit x minus 1, close the parentheses to end the absolute value, and then hit plus 3. And I'm going to get into an integer window, which has nice values. And let's go ahead and hit zoom 6. And that gets it into a 10 by 10 window. And you can look right now and see that the minimum value there seems to be at 1, 3. I wanted to show you how to use the minimum function here to approximate something. So at any rate, and it appears just looking at this, you can get the domain and range easily, the domain being all real numbers and the range being from positive 3 to positive infinity. But let's go ahead and use this function to calculate the minimum on the calculator. And so the way that you do that is you hit second and calc, which is above the trace key. So I hit the trace key, and then minimum is the third thing down, and I'll hit enter. And when you get a minimum, you have a function could have several minimums, so they might go all over the place. And so we'll get the left bound is just any point to the left of the minimum, and that seems to be to the left of it, so we'll just hit enter. And then for a right bound, we move the x to the right until we get a boundary point. We get something to the right of the minimum, and we hit enter. And then there's always this guess, we just hit enter, and it gives you an approximation of the minimum. Now I'm not sure why it has this decimal way out there, but the actual minimum value is 1, 3. Sometimes based on how they calculate or do these graphs on the calculator, you'll get a point very close to the actual value. But if this is rounded, it comes to the point 1, 3.